Okay, Algebra 1, we're finishing up the rest of this packet. Alright, so Jesus wants to start saving for college. His parents started a bank account for him, and it currently holds $325. He adds $50 each month. So automatically, we should be thinking, we've got an equation in slope-intercept form because we have one rate and one constant. What number is the rate? The 325 or the 50? Alright, I hope you said the 50. And which number is the constant? The 325, because it's the starting point. So this is my m and this is my b. So my equation, y equals mx plus b. We're going to replace the m with our rate of 50. So y equals 50x plus 325. Alright, before we move on, let's make sure that the direction of our slope is correct. We have a positive slope. Let's look back at the problem. He adds $50 each month. Should this be positive or negative? Alright, I hope you said positive because of the word adds. He's adding to that bank account balance, so it's going up. Alright, let's go ahead and graph it. Label the y-intercept, the slope, and your axes. Alright, we'll start off. This is my x-axis, and this is my y-axis. Alright, so looking back at my equation, I'm going to write it down here so I have it for reference. Alright, y equals 50x plus 325. Alright, my slope as a fraction, 50 over 1. So that means I'm going up 50 and right 1. Alright, my y-intercept as an ordered pair is going to be 0, 325. Alright, so looking at these numbers are kind of big, right? The 0, 325, and then 50. So I need to scale my axes because I definitely won't be able to plot this graph if I'm going 1, 2, 3, 4, 5, right? Because if I count up 50, I won't even have any room on the graph. So let's go to Desmos and see what a good scaling option is. Alright, so I'm in Desmos. I was using Desmos for AP Stats, so I had some stuff left in here. I'm going to write my equation. Y equals 50x plus 325. Looks like that is a very steep slope. Alright. So I could probably go by 50s. 1, 2, 3, 4, 5. So let's do that. So I'll count by 50s. So 50, 100, 150, 200, 250, 300, 350, 400, and 450. Alright, so I labeled my axes and I scaled them, right? Instead of having it be 1, 2, 3, 4, 5, I did it by 50 so that I could get to the right y-intercept. So if my y-intercept is 325, it's going to be right in the middle between the 300 and the 50. 325 is right in the middle between the 300 and the 350. That's the wrong spot right there. Because 325 is right in between 300 and 350. So that's my y-intercept. Alright, now I know that I'm going up 50 and over 1. So if I go up 50, I'm literally jumping right in the middle of 350 and 400. I'm going to the right one. So I end up jumping in the middle and right one. In the middle and right one. So here's my y-intercept of 0, 325. Right here. And this is my slope. It's going up 50 and right 1. So this is my graph. And when I say 1, I mean 1 month, right? So after 1 month, I should have 375. After 2 months, I should have 425. After 3 months, I should have 475, right? Because that's what my y-axis is for each of these. All right, use your graph to find a solution. Label it and write your answer as a sentence. Whoop, well, I just did that, right? So let's use this one right here, up at the top. So this x value is 3. I know that because it's on the 3 for the x-axis, right? And I tried to draw it right in between the 450 and the 500. So the number that's right in between the 450 and the 500 is 475. So this is a solution to my graph. 3, 475. Now, let's prove it algebraically that it's a solution. So if I have y equals 50x plus 325, I'm going to plug in 475 for y, and I'm going to plug in 3 for x. Let's see if this works. Yep. So I know that this is a solution. I know it because it's a point on the graph, and I plugged it in algebraically. Let's go ahead and write our answer as a sentence. So the 3 is the x, and the 475 is the y. So looking back, we need to define what our variables are, right? Well, we can look back at the rate to figure that out. $50 each month. Remember, y per x. So that means dollars is going to be our y, and number of months is going to be our x. The wording of our rate always tells us which one is the x variable and which one's the y variable. So our x is number of months, and the y is the amount in our bank account in dollars. Alright, so looking at this, my x is 3, and my x is the number of months. So, after 3 months, Jesus will have $475 in his account. Remember, because the y is the amount in the bank account per dollars. What's another solution that you could have used? Instead of doing 3, 475, we could have used this point right here. This point, the x is 2, and it looks like the y is in between 400 and 450. So that would have been 425. So can you tell me a sentence for this point using what we did here? So we had after 3 months, Jesus will have 475 in his account. What would my sentence be with this ordered pair? After 2 months, Jesus will have 425 in his account. Does it make sense that it's less than the 475? Yes, because it's only been 2 months. Here our sentence was for 3 months, so that makes sense that it's higher. All right, determine how much money Jesus will have if he continues this pattern for a year. All right, for a year. Well, my x value is in number of months. So what is my x input for a whole year? How many months are in a year? All right, I hope you said 12. So I'm plugging in 12 into my equation and seeing what I get for the y. So right now I have y equals 50x plus 325. And I'm going to plug in 12. So y equals 50 times 12 plus 325. Let me put that into Desmos. So I have my Desmos app. I'm going to put it in just like I see it. 50 times 12 plus 325. And I end up with 925. So that's how much Jesus will have in his bank account after a year, $925, if he keeps saving at the same rate of $50 per month. Let's go ahead and work through these problems. All right, so graph y is less than 2 over 3x minus 5. All right, my m is 2 over 3, and my b is 0, negative 5. All right, so I'm going to start off by plotting my b, 0, negative 5. Now my m is 2 over 3. That means I'm going up 2 and right 3. Up 1, 2, right 1, 2, 3. Up 1, 2, right 1, 2, 3. I go the other way by doing the reverse, down 2 and left 3. All right, so now I've got my points. I need to connect the line. So tell me, does this need to be a dotted line or a solid line based on that inequality sign? All right, dotted. Remember, if there's no equal to sign underneath it, it's got to be dotted because it cannot be on the line. So I'm going to go ahead and connect these with a dotted line. So if you wrote a solid line, that would be incorrect. It has to be dotted. Okay, so now looking at this, y has to be less than what we graphed. So this is what we graphed, right? This is our y-intercept and our slope. So if our y has to be less than that, is the y-axis less than that? See how it's right here? Is it on the right-hand side of the line or the left-hand side of the line? If y has to be less than this, it's on this side of the line. Do you see how the y-axis below is down here? So this is what I would shade. All right, graph y is greater than or equal to negative 2x. Oh wait, let's check our work on Desmos before I move on. All right. Does this look like what we graphed? Yes, it does. So we did it right. So always check your work in Desmos afterward. All right, so this one, graph y is greater than or equal to negative 2x. So what's my m and what's my b? My m is negative 2, and written over a fraction is negative 2 over 1. That's going to tell me to go down 2 and right 1. My b, there's nothing at all. There's nothing past that. There's no constant. So my b is actually just 0, 0. So I start off by plotting the y-intercept because that's the first point they give me. And then I'm going to use my slope to do the rest. So down 2 and right 1. Down 2 and right 1. How do I go the other way? Up 2 and left 1. I just do the reverse. All right, now that I've got this, does it need to be a solid line or a dotted line? All right, I hope you said solid because there's a line underneath it, which means equal to as well. So the solutions can be on this line. Over here, if it was a point on the line, it was not a solution to the inequality. Here, if it's on the line, it could be a solution. And I put the arrows because they go on and on forever. All right, so this is y is greater than. So this y is greater than our line. So should we be shading above or below? Should be shading above. See how that y-axis above is on this side? All right, let's check our work in Desmos. All right, looks like what we did. I agree. Okay, Let's keep going. Number 3. All right, I hope you noticed that number 3 is a special line. It only has one variable, and that variable is y. So remember, I don't know why I just wrote 10. All right, so if it only has y, I'm here. H stands for horizontal, and this O stands for 0 slope. So it's a horizontal line, and our slope is 0. We do have a y-intercept, and it's 0, 3. Remember, the constant is the y-intercept, so 0, 3. So I'm going to start off by plotting that y-intercept, and then I know it's a horizontal line. So it's going to be parallel to that x-axis. And now you can see why that equation y equals 3 makes sense, because every single point on this line has a y value of 3. All right, do I need to shade? No, I don't, because it's an equal sign. So the only solutions are actually on the line. Anything above and below won't work. All right, graph x is equal to -2. Okay, I hope you noticed again it's one of our special lines. This time we have x, so we know it's a vertical line, and the slope is undefined. So vertical line, my slope is undefined, and there is no y-intercept. Not applicable. There's no y-intercept. It doesn't hit the y-axis. It only hits the x-axis at -2. That's why it's x equals a number. So it's a vertical line at x equals -2. All right, do I need to shade with this one? Nope, because it's an equal sign. So the only solutions are points on this graph. All right, write an equation to model the graph below. All right, so to write the equation, I need the slope and the y-intercept. So looking here, I can easily identify the y-intercept. It's where it hits the y-axis, and the x value is 0. So my y-intercept is 0, 7. All right, let's take these 2 points and see how far I have to go to get from here to here. So to get from here, I need to go down 1, 2, 3. So down 3, and right 1, 2, 3, 4. So it looks like my slope is going to be -3/4. I could have also gotten that by our slope formula that we did a few days ago. For our slope formula, I would have taken 0, 7, and 4, 4, the 2 points that they give me, and I would have labeled them x1, y1, x2, y2, and plugged them into my formula. Remember, my formula is y2 minus y1 over x2 minus x1, and we'll always give that to you. So my y2 is 4, my y1 is 7, my x2 is 4, and my x1 is 0. 4 minus 7 is -3, 4 minus 0 is 4. So I could have gotten the slope that way as well. You get the same thing. So now that I've got the slope and the y-intercept, it's easy to write the equation. Y equals mx plus b. Y equals -3/4x plus 7. It's got my slope and it's got my y-intercept. All right, Ms. Lucas wants to track the number of students that come to tutorial each week. On week 1, 3 students show up. On week 2, 5 students show up, and week 3, 7 students show up. Graph the number of students in each tutorial. All right, well, let's make ordered pairs out of these weeks. So we'll make a table. So week number and students. So week 1 I had 3. Week 2 I had 5. And week 3 I had 7. So these are just ordered pairs that I can go ahead and plot. 1, 3, 2, 5, and 3, 7. So 1, 3, 2, 5, and 3, 7. So it looks like I have a slope of up 2 over 1, up 2 over 1. So it looks like I could go down 2 and left 1. and this is my line of students coming to tutorial. I can't go beyond this x-axis because I can't have negative weeks. Look, my x is representing the weeks and my y is representing the students. I can't have negative weeks and I can't have negative students. So it's only going to be on the positive side in quadrant 1. All right? That's it. Let me know if you have any questions on graphing linear equations or linear inequalities.